Hello everyone. So occasionally I will be recording some tutorial videos for this course. The goal is to show you how to work out some additional problems related to the topics covered in class. The way this is going to work is in class I will cover the main concepts and perhaps solve a couple of problems. And then in these videos I will do a quick review of the topic covered in class and work out some more problems. Today, I want to solve an additional problem on force vectors. But before that, let me review some basic concepts. In class, we discussed two different ways to add two vectors. They were basically geometrical ways, and they were the triangle addition and the parallelogram addition. Now the idea was you basically have two vectors as part of a triangle for triangle addition. And the way you find the resultant is by solving the geometrical problem of finding the third side. You could either use the law of sines or the law of cosines. The parallelogram addition, the idea was that the vectors that you are adding are part of the adjacent sides of a parallelogram, and the resultant would be to find geometrically the diagonal of the parallelogram. And you can still apply the law of sines and the law of cosines as required to solve for these two additions. The more useful of these two would be, in my opinion, the parallelogram addition, because most of the problems in your textbook follow or to ask you to find the resultant of two vectors that act on, or two or more vectors that act on the same point. So imagine two vectors in this plane, and if you were asked to add vector A and B, what you would do is basically think of both these vectors as sides or adjacent sides of a parallelogram and basically create that parallelogram either in your notebook or in your mind. And then let me just dash these lines to just convey the point that these are just moved, or the vectors A and B can be moved anywhere in the plane, keeping the magnitude and the direction same. And it's legal to do that, right? If the magnitude and the direction of a vector remains the same, it is the same vector wherever it's located, right? So now we have this parallelogram with A and B as the adjacent sides, and what we would do is, to get the resultant, we would just draw the diagonal, and essentially that represents A plus B. And as you know, you would be given certain sides or the magnitudes of these vectors and the angles that they make with either each other or with a reference axis, and then you can use the simple geometry to find the diagonal. So basically that's the parallelogram law of addition. There are problems in the textbook that ask you to do this in particular. You can choose to do that in some other problems, or you could choose to use my favorite method to add two vectors, which is nothing but resolve into components and add. So the idea there was that, let's say we have the same vectors A and B, right? And let me erase these lines to just leave us with A and B. And the idea of resolving into components is that I can pick each of these vectors. For instance, I can pick just A, take it to its side, and then have the vector A be resolved into its orthogonal components. Basically, I can have the x component of A. This that I drew is too steep to have a meaningful or a visible x. I hope you can see that small dashed line that I drew horizontally. And then you would have a y component. And what we would have is we could resolve A into its x component, which is the magnitude of A times the cosine of the angle that it makes with the x-axis, and the y component as the magnitude of A times the sine of the same angle. The way I like to think about this is that the component that shares the angle with the original vector would be a cosine component, and the component that doesn't share the angle with the original vector is a sine component. So I think that is a good way to remember how to resolve the components quickly. And similarly, I can resolve, or I can pick the vector b separately and have that resolved into its components in the x and y direction. Now these x and y, remember, are orthogonal to each other, so which means they are perpendicular to each other. Right? So now, for b it's the opposite. I've drawn it too shallow that the y component is barely seen. Anyway, the x component would be the magnitude of b multiplied by beta if this angle is beta, or cosine beta, and the y component would be the magnitude of b multiplied by sine beta. And the way you add a and b is just add their x components and y components separately. So be the x component of a is a cosine beta plus the x component of b, which is b cosine beta, times I hat plus the y component of a, which is a sine beta, plus the y component of b, which is b sine beta times j hat. So the way we get this, or the format that we get this, is called the Cartesian vector format. It is nothing but the vector that is the sum of vectors a and b. And as we've discussed in class, the magnitude of a vector of format xi plus, or xi hat plus yj hat is given by the square root of x squared plus y squared, and the direction of the same vector is given by the tangent of theta, which is the angle that is made by the right triangle with x and y as the sides of the right triangle that's not the hypotenuse, is equal to y over x. So for instance, if this is the x and that's the y, we get tangent of theta as that theta. So remember, it's always useful to draw this triangle to make sure you get the actual theta that's being asked in the problem. I mean, you can find a theta and it will still be meaningful, but unless you write what's asked for, you don't get any points for solving that problem. Anyway, let's move on to the problem that I want to solve today. So this is problem 2-38 in your textbooks. The problem essentially is there is some kind of a hook or bracket that's attached to a wall, and at the end of the bracket there are three different forces acting on a single point. There's a reference axis given, x and y. So it's always if the axis is given in the problem, I would advise you to use the same axis. It doesn't matter if you do or not, but to answer problems in the exam, I would advise you to use the same axis that's provided to you in the problem. If there are no axes provided, you are free to use your own reference axes. Anyway, so how do you approach solving this problem? Well, you have three different forces acting on the same point, right? You could use the parallelogram law of addition. But remember, the parallelogram law of vector addition is mostly used for two vectors. So for instance, since we have three vectors here, you would have to use the parallelogram law twice to get the final result. So we will choose not to use the parallelogram in this case. And we will move to use the resolving and adding way of vector addition. So essentially, what we have here are three forces, and what I can do is replicate or just pick these three forces one by one. So essentially, what I do is I have the same reference axis, x and y, and I'm going to replicate the same axis 3 times. And in each of these, what I'm going to do is draw these vectors by themselves. So I have F1 here, which I'm drawing or choosing red to draw, where I have F1, or the magnitude of F1, to be given as 50 newtons. And what's also given is a small triangle with sides. So remember, this indicates the slope of the vector, right? So it's essentially giving you the values of the sine and the cosines of the angle or that's useful to compute the components. We'll get there in a bit. Let's move on to the second vector, which goes downwards, in fact. So let me draw that downwards. I'm also using a dashed line to indicate the y-axis in the negative direction. And the angle that this vector makes with the negative y, so this is negative y, is 15 degrees. And the magnitude is 80 newtons. Okay, moving on to the third vector. We have a vector that's aligned parallel to the x-axis, which is convenient, really, because when we find the components, we wouldn't have to find its component in the y direction. So F3, the magnitude is given to be 30 newtons. So since that's the easiest, let me find its x and y components first. So we have its x component as 30 newtons, and the y component as 0 newtons, because there's nothing going in that direction, or the effect of F3 in the y direction is 0. Moving on to the green vector, we have, so remember, this vector is going downwards, right? So the first thing that you have to identify is that its components would be directed along the negative direction of y and the negative direction of x. So when you write it, the way I like to do this is write them with their signs. So what I mean by that is, if I write the components of green, I have the x as negative 80 times, it will be, think about it, will it be the sine or cosine? Since the F2 shares, or the negative y direction shares the angle 15 degree with F2, the y component will be the cosine. So remember, adjacent is cosine, opposite is sine. So this x component would be negative 80 sine of 15, and the y component would be negative 80, again, because the y is also negative, cosine of 15. And finally, moving on to red. Remember, the way that the information is given is that the slope. So if the vector f1 is directed in such a way that if you move three units along the x direction and 4 units along the y direction, you get you get the slope of the vector. So imagine if there was an angle theta here, the sine of theta would not be nothing but the opposite side, which is 4, divided by 5. And similarly, the cosine of theta would be the adjacent side, 3, divided by 5, right? So basically, if they are giving you a triangle that gives the slope of a vector, you are basically given the values of the sine and the cosine. Sometimes this 5 will not be there in the problem. What that means is you'd have to use the Pythagorean theorem to find the third side, that's the hypotenuse of this small triangle, to get 5 as the answer. So the way you do that would be to find 5, you would square or you would find the square root of the sum of squares of 3 and 4. Okay, so quickly writing down the x component, we have the magnitude, that's 50, times the cosine of theta, which is 3 over 5. And the y component would be the magnitude 50 times 4 over 5, which is the sine. So all these vectors are of the form xi plus yj. So to find the resultant, what you would do is just add the x components first. So add all 3 x components, which is 50 times 3 over 5 minus 80 times sine of 15 plus the 30 newtons times I hat plus 50 times 4 over 5 minus 80 times the cosine of 15 plus 0, because there's no y component for f3, times j hat, and never forget the units. So this is newtons. So the problem might not have ended here. Sometimes they would ask for you to find the magnitude and the direction of the resultant, and the way you do that is, remember, use these two formula, right? So you can try that yourself as an exercise. So that is the way you solve problems with multiple forces acting on the same point, and if they ask you to find the resultant.